G'day, welcome to March 2022 meetup, virtual meetup, AWS Aotearoa user group. My name is Chris Watson. I'm the president of the group, and thank you very, very much for coming today. So our agenda, basically first, kia ora and welcome. I hope you're all well, or if you're not well, you're only slightly unwell, given obviously the stage we're going through with COVID right now. We're going to just go through big thanks to our sponsors, then we're going to do a general update on the user group, and then we're going to go through our presentations, which we have 5 today as well, with Alice, Cameron, Mark, Saga, and Vivek, and then we'll be wrapping up. So yeah, this is our first meetup of 2022. As mentioned before, I hope you're all well and you're doing well during the COVID pandemic we're going through right now, and none of you are too sick or anything like that. We haven't had any physical meetups due to various reasons as well. So this is our first one of the year, and we hope to have many more meetups, both virtual and physical, throughout the year. Big thanks to our sponsors. The user group, we're a community-led and user-focused group where we're inclusive of everybody, but we do need money to pay for our streaming services, meetup.com, our website, etc. as well. And we're very excited to bring Consigna on board as a sponsor of the user group, and which will help us grow even further. And we're also equally pleased to have the continued sponsorship from Datacom. Just a general update. So we have a monthly newsletter for March posted in LinkedIn. Feel free to go there and read it, but some of the highlights are we need some speakers for April and beyond. If you want to come speak about AWS, whether it's 5 minutes or 30 minutes long, beginner or advanced, any sort of topic within AWS, would love to hear you speak as well. Do not feel you need to be an expert to speak as well. Beginners, you're more than welcome to speak if you've got something you believe will be useful to the community. We also want your feedback to help us run better. So any ideas you have in terms of what sort of events to have, how we should host them, anything on those lines, please come see us. Go to the LinkedIn newsletter to get details as to how to get in contact with us. We also, at the start of the month, had a special annual general meeting, as we've made some changes to our constitution, of which one of them is to give us non-profit status as well, as effectively a not-for-profit organisation. Another thing is we're working on our website right now. We're getting it redesigned, including a full te reo translation. And once that is done, we will then build and launch our new website. And the other piece of news is that right now, the Aotearoa user group basically has a Wellington and a Christchurch chapter. There is a separate user group run out of Auckland, hosted at AC3 and ran by Githika as well. That's completely separate, but we are very well far through progress in trying to bring the Auckland group into AWS Aotearoa. Haven't quite got across the line yet, but we're very, very hopeful that it will be the case. And hopefully very soon we'll be able to give you some more information announcements. So fingers crossed there. So now we come to our speakers for the day. We've got 5 people speaking today. We've got Alice Fage-Verlind, who's going to talk about EC2 benchmarking. We have Cameron Todd of AWS, who will talk about the Auckland Local Zone. We have Mark Goatley of Deloitte talking about his top 10 announcements for AWS for February and March. We also have Saga Donthanini, also of Deloitte, to talk about AWS Pinpoint. And lastly, we have Vivek Raja of NextStem Cortex BCI. He's talking about AWS Rekognition, and I believe Vivek is our first international speaker we've had, so that should be really exciting as well. So without further ado, I'd like to bring Alice Fage onto stage. Hello, Alice.
Kia ora.
Cool. We can hear you.
Hi.
Awesome. Okay, yes, we can. I'll hand over to you, Alice, and I'll just step backstage. So thank you very much, Alice.
Thank you. Oh, kia ora. So my name's Alice Fage, as I said. Thank you for having me to talk to you. I'm a geospatial developer in the topographic data engineering team at Toitu Te Whenua Land Information New Zealand. I'm just going to talk briefly about EC2 instance benchmarking, and maybe this is something you might like to try for yourself. So my team is working on a product called the Topo Processor. This basically uploads aerial imagery and processes it into a cloud-optimized GeoTIFF format, which is appropriate for web applications. And we also produce some metadata files to go with that. Our application runs in AWS on AWS EC2 instances using AWS Batch. So you can see the processes that you submit the jobs. It splits it up into batch jobs by aerial survey. So that's just a load of associated images flown at the same time. It runs a Docker image, which is based on a piece of software called GDAL, which is a nice image that they actually create, this organization called OSGeo, and that's open source. And the Topo processor code grabs the images from S3, converts them into COGs, the cloud optimized GeoTIFFs with lossless compression, so they're a bit smaller, and then pumps them out into another bucket where it goes into our GeoStore later. So when we are looking at the EC2 instances, there's a wide range of different instance types, as you probably know, and it's hard to choose which one's right for your jobs. So they're all optimized for different things. There's, as you can see, some examples there. There's C5 large, which actually isn't that large because it goes to 25 extra large, and the C6i. So the C is for compute optimized. That means it's got about, I think it's 2 gigs of memory per processor. So memory optimized would have like double or triple that or quadruple that. The C6i large, so that's again compute optimized. The 5s are the generations, so the higher the number, the newer they are. And I is for Intel. Nothing is also for Intel. G is for the AWS Gravitons, and A is for AMD. So we were really interested in what's going to give us the best price performance for our workload. So we took a look at our workload, and we found that the most intensive parts were the image processing, unsurprisingly, and also the file copying. So we thought, well, we'll test that. And we really wanted to explore the new AWS Graviton processors. The Graviton 2 was out in our region. Graviton 3 is coming out. They seem fast, and they're AWS proprietary ARM processors, so they're running on a different instruction set, but we thought that might be quite an interesting thing to try. And we had the opportunity to find out. Over Christmas, we did an innovation sprint where we pick things that wouldn't necessarily come off our backlog, but that are of value. So our solution architect, Blaine, picked a tool called Hyperfine. He said, this looks really cool, and indeed it was really cool. So we took the tool and we ran our GDAL image processing, and with GDAL you can tell it to repeat a set of commands. You can tell with Hyperfine you can tell it to repeat a set of commands a number of times, like in this case 3 times. You can tell it to do a warm-up run. There's all kinds of ways you can do it, and there's a number of different report formats that come out the other end. This yellow example is JSON format, which is very handy, machine readable, very nice. It's got a few different statistics in it, and it's also showing you each run. So in this case, it just did 10 runs. So in this talk, I will just talk about what we did with the image processing. So we processed a black and white image 50 times, and this is what we found we did it on 5 different processor types. At first, we did 4, the ones we had available. So that's the C6G large, and you can see that the timings, we basically took the timings, the mean timing, and we calculated it based on the US dollar per hour amount, and then we got a cost for the job that we ran. So the mean cost for the C6Gs, which is the Gravitons, that came out the cheapest, basically, followed by the AMD, then the C6i large, which is the newer Intels, and then the C5 large, which is basically what we're running on at the moment still. They came last. They're pretty old. Well, they're not that old, but comparatively old for a processor. And then after Christmas, Blaine, our solution architect, got given a preview of the C7G large, and it's pretty exciting to note that it was super duper fast, Don't know how expensive they're going to be, but it's definitely something that we're going to look into. And then we processed the color image and got fairly similar-ish results. I mean, the C6i actually came out first with the cheapest, but it was followed very shortly after by the Graviton 2, the C6G large, which basically the difference between them was speed. The C6i is more expensive per hour, but it was faster. And then trailing at the back, the C5 large. We should probably move off those when we can. And again, the Graviton 3, ooh, super fast. So yeah, definitely looking forward to that coming to our region. And then a couple of conclusions, well, a few conclusions that we came to. Yep, we are interested to try the C7G with our workload. We're interested to find out the price. The Gravitons in general have got really fast networking. So again, that will benefit us. Hyperfine tests can be a bit variable on AWS. I think maybe occasionally, because it's shared resources, there's just a little bit of a wait. So there can be a bit of variation in the runs. But if there's a real outlier, then Hyperfine will actually tell you about it, suggest you run it again. And there is the issue of compatibility. Your code may not run on the Gravitons if you're running on Intel-based architecture. For us, we're super lucky because the GDAL Docker image can build for either, but it will still take us a bit of time to get that running on the Graviton for our GitHub Action CI/CD pipeline. And the last file that if you really want to try something, you might have to wait a bit for it to come into batch, like the C6Is and the C7Gs. When they get into EC2, they do take a bit of a while to get even further into batch, and they roll out at different times at different regions. But it's also worth paying attention to if you're running on something like the C5, as soon as you can, moving to the C6Is, because you will save money because they are faster, but they cost the same per hour. And if you've got any questions, got about 2 minutes maybe.
Okay, I don't think we've got any questions coming through in the YouTube chat. We'll give somebody a few seconds to do so. Otherwise, we'll be moving on to Cameron Todd. So if anyone's got any questions, then please put them in the chat in the next few seconds. Otherwise, I think we'll be saying thank you very much, Alice. That was fantastic. And
I'd say try Hyperfine. It's fun.
Yes.
And free.
It's really good. And free, right. Cool. Okay, well, we'll pass over to Cameron Todd now. And so thanks, Alice, and we'll bring Alice back at the end. If anybody has any questions that they think about for Alice after she's finished, just put them in the chat and we might be able to come back to them at the end. So we'll hand over to Cameron Todd of AWS, and Cameron is going to talk about the upcoming Auckland Local Zone. Over to you, Cam.
Hi, everyone. Just checking that you can see my presentation okay?
Yes, we can.
Cool,
and then
great.
we can hear you as well, so all good.
And that's a good sign. Okay, great. Okay, yes, so as Chris said, I'm here to talk about the Local Zone announcement, which some of you may have seen. I've met quite a lot of you. My name is Cameron Todd. I'm a solutions architect based in Wellington, living in Lower Hutt, beaming in from my home office today. And yeah, so I specialise in the public sector. And I've been doing lots of work around our region announcement and now our local zone announcement. So that's what I'm going to talk about today. So yes, you may have seen late last year that we announced a region coming to New Zealand in 2024. That's still happening. Region is definitely being planned and everything's on track for that. And that's a full-blown AWS region, as I'm sure you're used to, like we have in Sydney or in Singapore or in Oregon. But about this time last month, we announced a local zone. So that was part of a big announcement. I think it was 33, in fact, that we announced all over the world. We already have 16 of those live just in the US, but we are now expanding that out to cover lots of different places, but amongst those is Auckland. So let me talk a little bit about what the difference is between these two announcements and how they impact each other, if at all. So, as I said, we have a region, right? That's coming to New Zealand 2024, exactly like every other region conceptually. The mix of services might be different, to be confirmed, but it's multi-zone, so there'll be 3 availability zones minimum. It'll have a wide range of services, so it'll have regional services like S3 or DynamoDB, but also zonal services like EC2, EBS, things that run in a zone and things that run cross-region. The model's the same, scalable, on demand. Everything's managed by us. You buy what you need, pay for it, and then turn it off when you don't need it anymore, and you pay by the second or minute or hour or whatever works for you. The control plane will be in New Zealand. So the control plane is the set of tools that actually manage all of the infrastructure. So when you log into the console, you're interacting with the control plane that controls the things that you deploy. And every region has its own control plane. The local zone, which is also coming to New Zealand, can be thought of like an availability zone, but not actually, in this case, in Sydney. So it's a small availability zone that will be in Auckland. It will have a limited set of services, and it will be zonal services only. So because there's only one zone, we can't do things like S3 or Dynamo because there's not multiple zones to spread it across. Also, the control plane, the stuff that manages the resources running in the local zone, will be in Sydney. So it's not a standalone environment. It's something that's homed to another region, in our case, Sydney. You can manage things there, interact with your VPCs in Sydney, but it's separate. It's smaller, it's got a smaller set of services, and the capacity is smaller. I've also included Outpost there, which has been available in New Zealand for a while, so I've spoken to some of you about that. That's where you actually order Amazon hardware that is deployed into a data center that you have responsibility for. So whether that's your own data center or whether it's a colo facility, you roll in a rack, you hook it up, and then you can manage it using AWS tools and run AWS services on it. But the key difference is that local zone, you can just buy an EC2 by the hour, whatever. With an Outpost, you have to order a rack and have a multi-year. It's a bigger commitment to integrate because of all the work you need to do to get it running in your data center. So for most use cases, region is still the best way to do it because it's running all of the things that you expect with AWS, certainly around availability and scalability. A set of other use cases, a narrower set, things like Outposts and local zones can be a good fit. And particularly important, I think, for at least my customers in public sector in New Zealand is that idea of data residency. We want to have our data physically in New Zealand. We might not want it, but we're required to do it by policy or preference. There's also another set of services called Wavelength, which we haven't announced for New Zealand. There's no plans, as far as I know, where we deploy AWS services into telco concentration points. So you might, for example, if we did it in New Zealand, it might be with Spark or 2 Degrees, where you can have very low latency interactions with things running on their network. We don't have any of that in New Zealand, but we do have them in other places. And then right at the edge, you have actual like IoT, snowballs and snow cones, which might run almost anywhere as long as they can be connected to the internet at some point to communicate with AWS. The principal benefit of this for most customers is the reduction in latency. So if you're running workloads in Sydney right now, you'll be aware that it really depends on lots of factors, but typically my customers see things like about 30 milliseconds of latency up to about 50, depending on what they're doing and where they are in New Zealand and so on. When we have infrastructure in Auckland, that will be below 10 milliseconds for latency. So the CloudFront nodes that we already have in Auckland, they have around that, like below 10 milliseconds. And if you're actually in Auckland, it's like 1 or 2 milliseconds. And that's the real benefit. So the original use case for these was actually for the film industry in LA, where they wanted to do huge amounts of data transfer and render and all of that sort of stuff. And even just shipping it up to Oregon or to San Francisco was too much. So we put local zones in LA. But yes, now that model's been expanded all over the world. As I say, there's a limited set of services. So LA being the original one is a little bit different. So if you've ever looked at that, which has been around a lot longer than other things, you'll see that it's got a wide range of services. All other zones have a limited set. So C5D, R5D, T3, and G4DN EC2s. just GP2 EBS, and then there's some tools like ECS and EKS for container management, and VPC to tie it all together, load balancers as well. Important to remember there's no S3, so things like EBS snapshots will go back to region. There's no RDS, so you can't have a database running on RDS in the local zone or span your RDS across the region and the local zone for replication. And if you wanted to have an application that was running in New Zealand for New Zealand users and perhaps in Australia for failover, high availability, or Australian users, you can't have a load balancer that's spread across both the region and the zone. You need to, you can't do that. So you can have an ALB, for example, in the local zone and an ALB in Sydney, but you can't have one that spans the local zone and the availability zones in Sydney. So just conscious of time, I'll just go through quickly how it all hangs together. So it's very familiar. Once you get access, your account's whitelisted for use of these. You'll be able to go into settings in your EC2 console and turn on the local zone. So you can see here I've gone to US West Oregon and turned on the local zones in LA. They're ticked as enabled. Then in my VPC console, or however else you manage your subnets, you can create some subnets in the local zone. So here in this particular region, I've got 4 availability zones set up as normal, but then I'm also incorporating a local zone with a dedicated subnet. And then I can just deploy my instance into that local zone, just like I would any other. And that goes with things like CK or CloudFormation. If that's how you're managing your deployments, it's just literally just specifying another local zone or another availability zone, and it will get deployed out there as long as you have access to it and you're deploying things that are actually supported there. So an application might look a bit like this. You have your standard stuff running across multiple zones in Sydney, and then you put your stuff that you want to have in Auckland into its own subnets in a similar, in this case, 2-tier architecture. The local zone has its own dedicated internet gateway, so you don't have to trombone out to Sydney if you want to do internet traffic one way or another. It'll be able to ingress and egress in Auckland. And we also have a direct connect gateway. Yes, so if you need to have some private link, there's ways that you can do that. Sorry, I got lots of kids yelling at me through the window. Then if you wanted to do an HA type arrangement, high availability, you could do similar sort of thing, but you would be, you wouldn't have the benefit of multiple zones in the same way that you would if you spread your subnets across multiple availability zones in a region. So all of these things, for example, that you're seeing on the right of this diagram are all running in the same local zone. So you've got sort of high availability from an instance standpoint, but not from a physical infrastructure standpoint. So I get lots of questions about this, and there's a real mix of things that I know and I'm allowed to know and that I can say and I'm allowed to say. So these are the questions that I'll cover off, and then I'll open the floor. So quite understandably, a lot of customers are a little bit confused about whether this replaces the region or what will happen to the local zone after the Auckland region is announced. And the answer is no, it doesn't replace it. And after the Auckland region is become generally available, the local zone will continue to run with Sydney as the parent region. It's very important to understand that the local zone is not an independent environment. It relies on Sydney. It needs a connection to Sydney to operate. So you can't deploy standalone workloads into the local zone without some level of reliance on Sydney, even if only for the control plane there. So even if you're not taking EBS snapshots or running workloads back in Sydney, you still need to use the tooling that's deployed in Sydney to operate your local zone. Internet traffic doesn't have to be routed through. I covered that. I get a lot of questions around Direct Connect. Unfortunately, that's still an NDA discussion. So NDA is non-disclosure agreement for those who don't know. So if you have an AWS account team, ask them, or you can just email me directly. So my email's on the front of this presentation, and I can share it after the call, and we can talk about that. I just can't talk about it in public. We've already covered local zone and outposts, and we, again, directional timelines for when the local zone is available. I can't share in public, but can be discussed under an NDA. But I can say that it will be available before the region launch, and the region is due to launch in 2024. Cool, and that's it for my presentation. I went a little bit over time. Chris, do we still have time for questions?
Yeah, I think we do. We've got a few questions in the chat, of which I think you may have answered some of them. So one person asked a question as to why there is no GP3 option in Local Zone, and I guess, is there any chance it's coming soon? Or
I don't have an answer for that. I could make an educated guess that I suspect that because the local zone is quite a small deployment by Amazon standards, we probably don't have the requisite tooling to manage GP3. We need to do a certain scale of deployment before that becomes practical, but there's no official answer to that. GP2 is the standard that we go with.
Yeah, cool. And there's another question which I'll slightly twist as well. Somebody's asked about whether there's a question for a South Island local zone. Obviously there isn't right now, but how far is AWS likely to go in its local zones? I mean, how many have they got right now?
So we've got 16 live with 33 announced. And we've also got, I believe, 9 regions currently in flight, meaning being built.
Right.
Yeah, I would never say never, but certainly I haven't heard anything to say that the South Island's being considered. And in practice, if you've got workloads that make sense to put in the South Island physically, then let us know, and that really helps us when we're planning for what we do next.
And potentially they could go outpost as well if it was appropriate for the workload, but that's obviously a bit of a case-by-case basis, I guess.
Absolutely, yeah. And even so depending on what you're doing, even running you can run a snowball device with high levels of compute. There's a few options there. So yeah, there's lots of options.
Okay, that's great. We're getting a few more questions, but we're kind of a bit short of time. So we might be able to go back to them at the end, depending on how we get through the rest of it. So that was fantastic, Cam. And we will now bring Mark Goatley of Deloitte onto stage to talk about his top 10 announcements for AWS for February and March. Hey, Mark, how are you doing? I'll leave it up to you. I can hear you fine and see you.
You can hear me?
Yep.
Sweet. All right. So yeah, this is kind of something I thought maybe we could do as maybe a regular thing. I'm not sure, kind of looking for some feedback, see if it's of use to people. I thought, we see so many announcements, and sometimes it's good to kind of revise them and yeah, just kind of refresh each month. See how we go. Happy for some feedback. So kind of just stepping through, there's no particular order for any of these, but one of the things that was announced recently, so S3 batch replication now synchronizes existing data. So that was a bit of an issue for some replication jobs that didn't have, if you already had files inside a replication, it wouldn't replicate them all, only new stuff. So that's a really good add-on to that. Also, if you're looking to get more badges and do some more training, there's some new AWS Skill Builder learning paths and badges around storage itself. So either object or block storage, you can kind of get a nice badge to go with those once you've done that training, and it just adds to the things you've done. Recently, it was announced it's the 10th birthday of DynamoDB, so that's kind of a cool milestone there. So it was back in 2012 when DynamoDB was first announced. 10 years is pretty good. Fully managed NoSQL database with single-digit millisecond performance. Lots of people using it, hundreds and thousands of customers doing a lot of workloads on DynamoDB. So that's a great milestone. A couple of announcements around Firewall Manager, now supporting versioning of the managed rule groups for the WAF, so that's helpful there. And also a new network firewall centralized deployment model, so you can deploy things in a centralized manner, which will make things a lot easier going forward. Also, AWS backup for Amazon S3. So this is interesting. It's often, people kind of go, oh, well, S3, it's all safe, the data's there, it's got durability, lots of durability. That's true, but what happens if you delete stuff that you're not supposed to, or someone comes in and deletes things? Now that we can hook up S3 into AWS Backup, that's going to make things a lot better for making sure that the data that's stored there is safe and the applications can keep running. We can restore back things that do occasionally get lost. So that's another great feature that's been announced. The Security Hub, so Security Hub just keeps getting better and better. So more controls around security best practices. That's good to see. That just keeps continually adding on more and more additional help to keep your accounts secure and your workloads all running nicely. So CloudFormation hooks, this looks quite interesting, and I think there's quite a few people interested in this. So you can now invoke custom logic and to automate your actions and inspect resource configurations prior to creating and updating CloudFormation stacks. So that's a feature I think people are looking for and help improve CloudFormation. Another service that just keeps getting better is Control Tower. So that's sort of a lot more functionality added, keeps getting added to. So now I've got more best practices that you can make sure that you're adhering to, including lifecycle policies and access logging for the access log bucket. So we know what's happening in that access log bucket, which is a great addition. Yeah, so a couple of extra things that are available there, including KMS configuration for encrypting the config data, which is a good thing to do. Another addition is around billing. The billing console has been updated. There's a new homepage experience there, which is a great improvement. There's also a new billing conductor, which I thought was kind of an interesting name for a new service. But that's definitely helpful around sharing your reserved instances and savings plans, and just making that easier to do across multiple accounts. Those of us that are looking after customers or your own environments that are multi-account, anything to improve that is a great thing. And there's been some updates around Migration Hub. There's a new refactor spaces ability to help when you're refactoring applications and doing migrations, so that instead of just doing lift and shift, you can use the new Migration Hub refactor spaces to help move that into a different application rather than just lifting and shifting things. Some new updates for Lambda. .NET 6 is now supported, so that's helpful if you're wanting to take advantage of those new features available in .NET 6. And one of the other good things that I'm interested in was the well-architected framework has been updated with new lenses. So this is just to target the framework a little bit to different workload types rather than just kind of a generic framework. So the streaming media lens, the SAP lens, and the games industry lens, and a hybrid networking lens have been added. So that's a new updates there, and they've updated the machine learning, data analytics, and management and governance lenses, as you'd expect as those services kind of change over time. Another new thing around Route 53 that's popped up is geolocation and latency-based routing. We've had that in public Route 53 for quite some time, probably right from the start. But interesting to notice that you can now do that for private DNS now in Route 53. So that's certain use cases that will be very helpful. One of the other things that was interesting around this new KMS announcement is they're now supporting hybrid post-quantum key establishment protocols for TLS. And this is kind of interesting because what do you do in a post-quantum world? It's good to know that AWS is helping try and work through that with the the NIST post-quantum cryptography process. So that's a good thing that everyone is actually working on how we're going to cope after the quantum computing turns up. And another migration update. So the application migration service now supports Windows 2003, 2008, 2022, and Windows 10. So this is kind of good because being able to migrate older applications out from older workloads, older Windows 2003, 2008, all not supported anymore. Very hard to do anything with, but AWS have made making that easier to deal with, so we can migrate the applications from those older operating systems, and there's a few extra updates there. So they now support IO2 and GP3 volumes in the staging area for that migration service. So that's just a few extra features there. The other nice update in the last few months was the carbon footprint tool. So I could have done with this probably about last year, where you can now go in and find out what your carbon footprint is very easily, the click of a button, and that takes all the work out of that issue. Especially if you're working with customers or company that has to report the carbon footprint, that will make your life a lot easier. And getting through these now, there's a new option for multi-AZ RDS using PostgreSQL and MySQL. So now you can have one primary and two readable standby databases across 3 availability zones. So this is for write transactions, optimized for write transactions, and is ideal for your workloads that require lower write latency and automated failovers. So along with the other backup additions, the updates to AWS Backup just keep coming. So they're now supporting AWS Private Link. So you can now back up workloads across a private link, which is a great little update. The big update, Cameron's covered it all, that the new local zone, after announcing the new region, that was a great update. Everyone's pretty excited. The more workloads the additions to what we can do here in country is all good. And I just got one more. I thought I'd do a bit of a plug for Understand Jeff Barr is going to be on the local fireside chat. It'll be up on the AWS Twitch stream. That will be really good to hear from Jeff speaking about the AWS announcements for here in New Zealand. So yeah, looking forward to that. And that is me.
Cool. Thanks, Mark. There was a question asked as to whether you'd be prepared to share your slides as well.
Yeah.
Yep. Cool. We'll figure out how we're going to do it, and we'll announce how we're sharing it through LinkedIn, etc. as well. So yes, we will share the slides. Just conscious we're just a little bit over time. So people have questions for Mark, just please put them in the chat, and hopefully we'll come back into the end. But for now, big thanks to Mark. Some really great stuff in there, and we will put you backstage, and we'll bring up Saga from Deloitte to talk about AWS Pinpoint. Hey, Saga, how you doing?
Hey, Chris, can you hear me and see me?
I can hear you and I can see you, so I'll hop off backstage. Thanks, Saga.
Thanks. Hi, everyone. Good evening. I'll quickly jump into the topic. So today we are going to cover AWS Pinpoint overview. So this is the agenda. Basically, we'll cover it in the next 10-12 minutes. So the first is what we look at what is AWS Pinpoint and the communication channels supported within the Pinpoint. and the segment concepts within the Pinpoint, and also campaigns and journeys. And also we'll see some use cases where we can use Pinpoint. And I'll talk about a reference architecture, which I worked recently. So AWS Pinpoint is a managed service, supports outbound and inbound communications with users. And this is a scalable to really 1 billion users. I worked in a scenario where it scaled for 1 million users. And with AWS Pinpoint, you can segment your audience based on a criteria and target a specific criteria group of people to send notification, basically to improve your product uptake and stuff. So this particular tool supports channels like email, SMS, push notification, voice, and in-app notification, and also the custom channel. Basically, custom channels are you can integrate with any other third-party notification engine to run those notifications. So capability of segmenting customers based on their attributes and handling of updates to underlying data with the Pinpoint APIs. And also you can create campaign and execute campaign once you create a segment using a defined parameters to group your audience. Then on top of that segments, you can basically target those segment of audience by launching a campaign. And also there is a concept of journeys within the Pinpoint. Journey is basically nothing but it's a customized multi-step engagement experience where you target a customer based on their action. You send follow-up messages. And also you can, for all these channels, you can maintain a content in the message templates where you can use within when you are launching the campaigns. And you can personalize the content with the first name or last name, like any other details which is personal to that user. Moving on. So it's a bit of overview of the communication channels supported. So obviously email basically leverages AWS simple email services in the background, and it can send emails. And with a Pinpoint events and stuff, you can monitor who opened the email and inbox placement, and also clicks and opens. SMS, there are two types of SMS with a inbuilt SMS channel. One is transactional and one is promotional. Transactional is a bit time critical, whereas promotional is not time critical. It's basically takes a less priority. I think this is the most effective channel because you get a user attention immediately, but obviously it's an expensive as well. Push notification, this is a most affordable method of sending important and time sensitive notification, because whoever using your mobile app will get this push notification. And voice, this particular channel is leverages text to speech capabilities from AWS Poly and delivers that message by the message body, whatever you stored in the message templates, by calling the destination number. I not use this channel personally, but I have basically, I think even there is a new feature coming in within AWS Pinpoint where you can integrate AWS Pinpoint with AWS Connect. So which is, I think, more mature option than using an inbuilt voice option in the Pinpoint. In-app notification is basically for your web browser and web apps, so mobile apps. When users are logged in and doing stuff, you can send a notification to those targeted audience. So custom channel, this is a channel basically to deliver notification via third-party tools. Like you can basically send a send a payload to out to a Lambda, and that can in turn call a Twilio or a Amazon Connect or a WhatsApp API or something. So you can send a notification to in a customized way which suits to your requirement. And all of these above events can be streamed to S3 Redshift for all other stuff for analysis purpose using Kinesis streams. So Pinpoint segments, basically data can be loaded into Pinpoint using CSV files, which is not really a very good way of dealing with the data, but like API calls integrated with your mobile app or a web application, so that the real-time updates happens whenever the user does an action. But there is an option to import with a CSV file as well. So there are two types of segments normally. One is imported segment. So whenever you import a data with a CSV file, that is kind of a static segment. Whatever data contains in a CSV file, it creates a static segment, which is not a dynamic. And there is a dynamic segment. So dynamic segment, basically a group of people with a defined parameters, a group of people who exist in Pinpoint. So you can group them with some attributes like a region, the app type they're using, the mobile device they're using. And dynamic segments is basically, I'm just reiterating that a group of endpoints meet user-defined filters. And these dynamic segments are very useful feature in my view when automating a user journeys. So the next topic is campaigns and journeys. So basically, as I told, campaigns are executed using the selected segment. It can be on dynamic segment or imported segment, and you basically select a channel, SMS, email, or other channels, and you select your message template, and you can send that notification to the selected people. And journey is basically a kind of a workflow where you engage people to and prompt them to do an action. Just an example, in an e-commerce website, you add stuff to cart, but you don't purchase. And with the Pinpoint capability, you can basically follow up that person to go ahead and purchase it for X amount of time. I mean, you can add like a wait time in between each reminder, and the user only exit the journey when he completes the purchase or after X number of reminders. Some kind of customization you can do around it. So Pinpoint use cases, and in my way, it can be used in to segment users and contact and notify them using various channels mentioned in there. And it's definitely a very suitable tool for marketing campaigns and digital user engagement scenarios, and can be easily integrated with your website or mobile apps using SDKs. And you can do a regular update to user attributes within the Pinpoint. So based on that, the dynamic segment gets updated. So users fall into the segment or move out of the segment when no longer meet that criteria. And also you can trigger journeys. You can put events into Pinpoint. It's like somebody opens a session, that can be an event in the Pinpoint, and that can trigger a journey, a notification to that particular user. So you can configure that too. And there is this custom channel which can be used to not only notify people, notify a person using WhatsApp or Amazon Connect or Twilio, but you could use it to trigger other events to our downstream systems. You might not want to, you have other options obviously, but Pinpoint, if you're using Pinpoint for something else, maybe there's an option with a custom channel to pass on events to our downstream systems as well with a custom channel. So can be used to integrate with AWS Connect, as I told earlier. And it is very useful in a large volume of automated outbound calling, especially banking or financial sector, where you have to make a large volume of outbound calls. AWS Pinpoint, you can segment people there, and with the custom channels, you basically integrate with AWS Connect with some outbound flows, and you trigger basically you can do a high volume call, automated calling. Okay, let us look at reference architecture, which I worked recently. So this is basically an event-driven architecture using a lot of AWS services. The use case here is we have multiple sources of data, where one source we get the user details, and one source we get the user contact details, and another source is a live feed like of user actions. And this all data comes and lands into a S3 bucket, and there is a glue job triggered based on this data to join this data and transform it and put it into a DynamoDB. And as soon as DynamoDB gets inserted with the data, there is a Kinesis streams triggers a lambda function which reformats the data, because AWS Pinpoint has to have a column names in a certain way. So that lambda has that mapping with that, DynamoDB. This column belongs to this column in AWS Pinpoint. So that reformatting and mapping happens in lambda logic, and it updates AWS Pinpoint with the API calls. Once that is updated, there are dynamic segmented created with a free, with a criteria. So whenever new people land into that dynamic segment, there is an automated journey which triggers uh, every 1 hour to send notification to those people who fall into this particular criteria. And the journey has a very good setting that you can choose how many times a person can enter the journey. By default, one person can go through a journey once. So since we are using custom channels here, it will invoke a lambda after after the journey execution, and also streams the events to S3 bucket, and where you can query it using Amazon Athena. And lambda process that a payload, and obviously the logs are loaded into CloudWatch, and then puts the information into SQSQ. And there is another lambda which logs into a monitoring database, campaign monitoring database, and calls the Twilio API to send the SMS. And when a message is delivered to the user, the delivery notification comes back to AWS API Gateway, and from there again back to the campaign monitoring DB, where it says whether message is sent successfully or message is failed, and those kind of status comes back. Even the user can reply to the SMS, then that will land in the campaign monitoring DB, which we can further design, events like, you can integrate with the Lex chatbot to reply to that message, those kind of scenarios as well. There is an Amazon QuickSight, which on top of that campaign monitoring DB to monitor how many messages we are sending daily, and any other stuff. And also we can create a platform events which can feed back the status of this thing to the source systems, so it can completely go around. Yeah, this is a very high level kind of overview of AWS Pinpoint, and yeah, I think it's takes a bit more time to go in deeper, but in today's we got like less time, so I'm just wrapping it here. Any questions, please feel free to ask.
Hey, sorry, I'm back on stage.
Yeah.
So one question we have is, does Pinpoint store any analytics data?
I did not get that question, Chris. Sorry, can you please repeat?
Okay, so I'm just repeating a question from YouTube. So somebody's asked a question about, does Pinpoint store any analytics data? My impression of that is that likely to stream it to other services via Kinesis. Was that correct?
Yeah, it also has an inbuilt analytics and reporting stuff, but it's normally does that for inbuilt channels. But if you are using custom channels, you can build analytics based on the events which can be streamed to S3 bucket or Redshift or EC2, and using Athena and a QuickSight, you can build custom dashboards as well. But it has a very less analytics capability in my view.
Okay, and there's a question from Stephen, which is a pretty tricky question. It's popped up now. In the reference architecture, why is the initial data into S3 and then Glue instead of using Lambda, SQS, or Kinesis as well?
Yeah, because the data sets we are dealing with is like a bit different. We need to have a ETL, like extract and transform and load kind of service rather than Lambda. So that's the reason we selected Glue, because that's an appropriate thing for the ETL kind of process.
Right, so it's all to do with your use case, and somebody's pointed out on YouTube that Kinesis isn't cheap either, which is probably true as well. Well, we've got another question. Okay, we'll try and wrap this up as the last one because we're a little bit out of time. Any consideration for opt-out from campaigns?
Yeah, that's a very good question. I think Pinpoint does have an opt-out option. You can basically when you segment the people, even the people opt out or part of a segment, the Pinpoint wouldn't send a notification to them. It's automatically exclude people who are opted out. You can manage opt out and unsubscribe stuff with a Pinpoint.
Okay, cool. If anyone's got any other questions, just put them into the YouTube chat. We might comment in there, or we might come back to it at the end, depending on time. But we need to move on in our time. So Saga, that was great. Thank you very much. And our last speaker is Vivek from NextStem Cortex BCI. Now, Vivek is based in India. So Vivek, I believe you're our first international speaker. So welcome, and I'll hand over to you. And I'll just make sure I can hear you and I can see you before I pop off stage. So I cannot hear you. I cannot hear you, Vivek. Still not yet. Okay. I can see you fine, Vivek. I can see your presentation, but I cannot hear you. So, cool. Okay, we'll just give us a couple of minutes since we're live. I'd just like to reiterate that for anybody who'd like to speak, either a virtual meetup or a physical meetup, please reach out to us. Just go to LinkedIn and check our March monthly newsletter to for our channels to reach out to us. As I said, 5 minutes long, 30 minutes long on data analytics, or anything on AWS is great to talk about as well. Do not feel you need to be an expert as well. Yes. Cool. Okay, so we might just, I don't know what we can do here. Vivek had sound before we started, so hopefully he will get it back in a few seconds. You're still completely on mute, Vivek, as well. We'll give him a minute, so just hold tight. And technical details in a live stream, it's always a little bit hard as well, but hopefully good. How about we say we'll give people 3 minutes. So if you want to go grab a drink or anything like that, then do that, and we'll hopefully be kicking off at 5:30 New Zealand Daylight Savings Times.
I think that's.
Yep. We can get you. So okay, we can hear you. Actually, so hopefully nobody's popped away because of Vivek. I just said gave people a 3-minute break. So okay. I don't know if anyone left or not. How about we do the? I don't know. We'll just keep going. We'll decide. We'll keep going. Yep. Okay, so Vivek, we'll hand over to you. You can hear you, can see you, and got your presentation. So I'll pop back off stage. So thanks heaps, Vivek.
Yep. Thank you for that, and thanks for having me as an international speaker. So hello everyone, I'm Vivek. I'm AWS Machine Learning Hero. I'm also organizer at AWS User Group Madurai from India. So and also thanks to Danny, who is also from my hometown Madurai for this collaboration as well. So I'm working as data scientist at NextStem, so which actually builds brain-computer interfacing technologies and stuff. Do check it out. And you can follow me in Twitter at VivekRaja007. So today's talk does not have any presentations. It will be just a demo with some cool use cases that you can use with Rekognition. And it will be very simple use cases, so bear with me. And let's get started. So before we actually do jump into the use cases, let's need to iterate on two things. The first one is, what is Amazon Rekognition, to know like before we enter the service. And secondly, why does Amazon Rekognition exist in the first place? So we'll try to answer those two questions first, and then we'll see the demos. So what is Amazon Rekognition? So Amazon Rekognition is part of AWS AI Services suite, and it more concentrates on image and video processing and machine learning techniques on that. And that answers the first question. Coming to the second, why does it exist? So imagine if you're a machine learning engineer, you have to invest a lot of time, effort to build out a machine learning model to actually do some predictions and so and so. And that might be actually a simple use case which is iteratively performed by many people. So Amazon comes up with a suite of AI services which is actually boost your business productivity by just reusing the models, and then you can leverage in your applications. So we can build out an AI intelligent applications within minutes, and let's try to see how we can do it. So I'm going to discuss 5 different use cases today. So the first one is how to detect labels in an image. So right now I have all my images set up in my SageMaker. So, but this can be actually run in your application, in your CLI, or even a REST API. So to make it much more simple, I prefer Python. So let's roll with that. So right now I have 2 images, and I'm passing that to Amazon detect labels of Rekognition client. So I'm actually importing Rekognition, and I'm calling the detect labels, and then I'm trying to print what I'm actually the Rekognition see in my images. So the first one is a classroom image with kids in that. So let's try to see what Rekognition has actually able to detect over here. So it has detected there are person, human, school, kindergarten, classroom, indoors, rooms. So there are 7 labels which were detected, and these represents confidence. So that represents like how confident is that prediction made by our Amazon Rekognition. So it is 99.48% confident that there is a person and figures of persons available in the image, and it's human, and it represents a school, it represents as a kindergarten as a subset, and also represents a classroom, and it's an indoor and room and so on. So I guess that's pretty much sums it up in one single image, but let's try to do a complete another one. So yeah, so this is an F1 race. So I guess like 2022 season just kickstarted with Bahrain Grand Prix. I guess you are also an F1 enthusiast like me. So yeah, let's see what really Rekognition has to do with here. So it has detected that there are car, perfect, and it's an automobile, again, yes. It's a vehicle, yes, that's a general one, and transportation, and of course it even identifies that the label belongs to Formula 1. That's interesting, and it represents driving, and these are the 6 labels our Rekognition has come up with. So driving actually represents only 57%. I guess the reason is the Rekognition is not able to find out whether the cars are moving or is it parked. Maybe that's the reason. And yes, of course, it can detect more labels depending on the picture you pass and the confidence how much you want to really use it. So that sums up the first use case. Now let's go with detecting faces. So for any image or any computer vision techniques, detecting a face and also the emotions which is expressed by a person is very important in terms of many things. For example, Snapchat uses it, so in filters and so on. So that's one typical example, but let's try to do it very simple. Again, I'm importing the client Rekognition. I'm passing the detect faces API, and right now I'm actually going to call one image, so which is Heisenberg, which you might be really familiar with if you're watching Breaking Bad. So yep, so let's see what are the insights we got from it. So the detected face is between 43 to 51 years old. Yep, probably. And what's the age range? What's a beard? So beard shows it's false. But of course he has a French beard, but there's only 62% of confidence on that. And what are the emotions which is showed by the person in the image? So sad is only 48%, disgusted is only 27%, and calm is 4.5%. He seems a little bit angry on 2%, happy as nearly 0. And these are the emotions which Rekognition feels that the person is exhibiting. And eyeglasses, that's true. Yep, the person is wearing an eyeglass. And he has his eyes open, that's also true. And the gender is 99%, he's a male. And also it gives you the facial landmarks. Where is your eye situated, where is your mouth, where is your beard, everything is situated, so you can pick out each and every facial landmark and part of it to work on that. So yep, those are where is your nose, where is your mouth, and so on. So there are a lot of stuff which you can meddle with. And of course, let's come to other stuff. So is the mouth open? False. Is the person has a mustache? No, that's false. And what's the quality of the image? Is the person smiling? And we actually saw if the person is wearing glasses, but is the person wearing sunglasses or not? So glasses were true and sunglasses were false. So it can distinguish very minute details as well. So how many faces were detected in this particular image? It's only one, but if you can pass an image with n number of people, you can collect the same details for each and every person individually. So that's the power of Rekognition within a couple of seconds. And third one is one of the interesting way of doing it. So it's celebrity recognition. So it does identify celebrities from a suite of celebrities collection. Let's try to do one thing. So what I'm going to do is I'm going to pass one image of celebrities and one image of who is not a celebrity. So I guess you must be very familiar with this image, right? It's the famous Oscar selfie. So I guess you can identify the actors. We have Bradley Cooper, we have Ellen DeGeneres, we have Jennifer Lawrence, and so on. So let's try to see if Rekognition actually can pick out these celebrities from here. So yep, it has got Jennifer Lawrence, and it also points out to the wiki data as well as the IMDb profile of them as well. So Jennifer Lawrence, Ellen DeGeneres, and Meryl Streep, Julia Roberts, Brad Pitt, like even though the Brad Pitt's image is very unclear and only partial face is visible, it can still find it out. And we have Kevin Spacey, we have 7, it was able to only find 7 celebrities out of here, but it's pretty good. Now let's try to pass a person who's not a celebrity and see what's the results going on. So which is obviously me, and I'm not a celebrity. So I think Rekognition, I can vouch that the Rekognition is working very perfectly. And coming to the fourth use case is text detection. Again, the same scenarios. We are importing our Rekognition client and we are passing the text, detect text API. I'm going to pass a meme and see what the text which I can get it from there. So the meme actually has a SpongeBob SquarePants with a caption saying, "My computer seeing me use it to shop a new computer." Let's see if the Rekognition can actually pick out the text from that image. So what are the texts which has detected? So my computer seeing me use it. So that's 100% to shop for new computer and so on. So, and it also can recognize each and every single individual phrase as well. So my computer seeing and so on. So, and what's the confidence? It's 100%. So which is pretty much confident it can actually do optical character recognition as fullest. So that's one interesting thing. And now comes my favorite part of the Rekognition, which is PPE detection. So personal protective equipment. So that includes your helmet, your face masks, and so on. So to make it much more interesting and to the current scenario, let's try to see if our Rekognition can identify if a person is wearing his face mask properly. So what I did before the session started is like I took a picture of myself wearing a face mask, which I have right now with me here. So okay, so and what I did is I took 3 pictures. So one of me wearing a face mask, one without it, and one partially wearing it. So let's try to see how Rekognition actually does job here. So it's all pretty basic stuff. You can go through the code a little bit later, and I think it's pretty much straightforward. So the first image is me not wearing a face mask. So I have a red bounding box showing that I'm not wearing a face mask. And second one is I'm wearing a face mask and it really marked at the face mask with a green bounding box. So which means it can actually detect personal equipments such as face mask. And third one is I'm still wearing a face mask, but I'm not wearing it properly. So even PPE detection can actually identify if a particular equipment is worn properly or not. So that's interesting. So right now, since we are still reeling from the COVID difficulties and consequences, it's better that we wear a face mask to protect ourselves. And this can actually have a plenty of use cases if we can think to. And let's make it much more interesting. What if I stream a video and it tries to identify the face mask detection? So let me quickly show you a video of me having it. So I'm wearing a face mask, then I'm removing it. I'm not actually properly wearing it. Then again, I'm trying to wear it back. Then once again, I am trying to remove it. So let's try to see how our Rekognition can identify this particular image. So going back here, so I'm using OpenCV2 to get all the frames as we do, and I'm actually passing each frame to the stuff. So what I'm going to do is whenever there is a face mask identified, I'm going to display that frame. I didn't actually do it very much properly, so you might see an RGB version of that particular frame, but it's totally fine. So it's processing every single frame, and initially I didn't have my face mask. And when I actually have my face mask, which is actually true when I'm trying to wear it, so it shows that, okay, I'm wearing my face mask. and once again everything is true, and once again when it again goes to false, and again I'm actually wearing my face mask properly, so it's again true. And then there is a third image where my face mask is very much perfect, and yep, this is one such instance. And yep, now what if I try to remove it? So what does our Rekognition do? So it's still true everywhere, so let's do. So actually right now I removed it, and my Rekognition actually perfectly worked well, and it showed false. So even though a person actually wore a mask, and if he removes, we need to identify that as well. So it works seamlessly with your integrations such as Panorama or your Edge streaming capabilities with Kinesis and so on, so that you can actually leverage Rekognition from that. So it's false, and then yep, again I'm wearing my mask, which is again goes to true, then it can work real time. So I guess that sums up my presentation for today. So we actually saw five different use cases of detecting labels and doing facial recognition, and we did a celebrity recognition, and we did an OCR of text detection from images, and we actually saw a real-time best use case of personal protective equipment of wearing mask or not. So that is my talk today. I'll be making this code base available soon, so that you can have a look at it. Of course, I'll remove my pictures for privacy and everything, but yep, still it's available. I think that sums up my presentation. If you have any doubts, you can ask me in the chat, and I would be really take to do something.
Cool, thanks, Vic. That was fantastic. We've got a few questions, actually one main question in there. It's a bit of a speculation one. Is Daniel's wondering what it would be like in terms of results of if you were a dark mask and so forth. Obviously you haven't tested it, but what would your feeling be if you did the same thing with, say, a black mask or something like that?
Oh, okay. Yeah, actually, it pretty much identifies all sort of protective equipments in all different phases. For example, it can identify a construction hard worker in white, yellow, and darker colors, and it can of course identify if I wear a black mask as well. So it works perfectly fine. I can put out an example in my upcoming sessions as well.
Okay, cool. And maybe you need to create a AWS machine learning heroes code to recognize machine learning heroes, because obviously it's a
yeah,
so
maybe soon. Yep.
Cool. Okay. I don't think we've got any other questions for now. If anyone's got any questions, just pop them in the chat. What we'll do for now is we'll bring back next. Sorry, I've got a question. Sorry, we've got a question from Dan. Sorry, I missed that. When are you going to show the active electrolyte system, whatever that may be?
Okay, so that's part of BCI technology, which my startup is really working upon. So I guess I can show the capabilities of brain-computer interfacing in some better version, and in a separate session maybe, to explain what all cool stuff that a brain-computer interfacing has and how we can actually leverage it. Yep. So thanks for asking that. And yep, I guess one more question.
We do, and we've got quite a tricky one on, or two tricky ones actually. One is on deep fake, as to how good Rekognition would be of recognizing a deep fake of, say, Ellen DeGeneres or something like that.
Oh, okay, that's an interesting question. So I haven't really tried it out, but I would really come up with results. But my best guess is I think Rekognition won't be able to identify the difference between a deep fake and a version. The reason is deep fakes are the Rekognitions are only designed for productivity based use cases, and it cannot really tackle these kind of edge cases like deep fakes and so on. But if you have to really do it, I think we have to take an extra step of leveraging that. But of course, I will try to present a good session. Like, I will try to work it out on whether it can identify a deep fake or not. Probably that's one interesting debate that we can have it later.
Yeah, I guess it would be pretty hard. And someone has also asked a very hard question as to whether it can distinguish twins. Presumably identical twins, I suspect is pretty hard.
Yeah, it's pretty hard, but it can definitely identify as two persons in one image. So, and it can actually tag images based on the actions and several facial landmarks and the actions which the user is performing in an image. So my best case is it can actually distinguish twins, provided that the two twins are available in the same image, And if it's a different image, probably that might also be one single edge case which Rekognition might not actually be able to tackle. But again, that's one debate. We can really check it out again.
Cool. Okay, so what we might do is we might bring all our speakers back onto stage. So if we can get Alice, Cam, Mark, and Saga back, it'd be great. Cool. And if we could get my presentation on this up back as well, that'd be great. Not that we really need it, but obviously big thanks to Alice, Cameron, Mark, Saga, and Vivek for talking today. If you've got any other questions, then gosh, I don't know, maybe put it into the YouTube channel or post on LinkedIn as well. So our next meetup date and location is TBC. Hopefully going to get some physical meetups at some time, but that's all going to depend on what's happening with the COVID levels, etc. as well. It may be virtual as well, and hopefully some things in Christchurch and Wellington physically, and hopefully we'll have Auckland on board as a chapter very soon too. Also thanks to Sebastian and Terence for their backstage work on helping this stream through today to everybody, and obviously thanks to everyone who's came and watched and everybody who's asked any questions. As I mentioned earlier on, we are really keen for speakers, so please reach out. You don't need to be an advanced user to speak if you want to talk about something to do with beginners as well, and like 5 minutes to 30 minutes in any sort of topic on AWS will be greatly appreciated. So we will call that a wrap, and I wish you all a good day, and I hope you don't catch COVID as well, which is obviously quite pertinent right now. So thanks heaps to everybody who's helped out today, and goodbye.